Well, hello. Today we're going to talk about Saxon Course 2, Lesson 42, and this particular lesson focuses on repeating decimals. Now, repeating decimals are really not all that difficult. You just know that they repeat. They go on and on and on and on, and they never end. So, got a little vocabulary that we'd like you to write down here. Okay, a terminating decimal has a remainder of 0. So if you do the division, the remainder, it works out perfectly. There is no repeating decimal. It's terminating, or you can say it stops. It doesn't go on. That's what we call a terminating decimal. Now, today we're really focused on repeating decimals, but we have to know the difference between the two. So, here is the definition of a repeating decimal. A repeating decimal is the result of a division problem that either repeats one number or a pattern of numbers like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and that is called a block, a repeating block. Okay? Here are some examples. 7.16 with this little line above the 6 actually means 7.16666 forever and ever and ever. Okay? If we have 0.181818 and it keeps going on and on and on, then we would write it as 0.3 with the line above the 1.8, because that tells us that it goes 1.8, 1.8, 1.8, 1.8, and the 3 is not involved. It's very important when you draw that line, that line above the repeating part, that you don't get sloppy. If you get sloppy and you draw it over here above that 3, then me, meaning the teacher, or anyone else who looks at your paper, is going to think that you mean 318, 318, 318, 318, when it is actually 18, 18, 18. So that is important. You can't get sloppy with these. Okay? Now, when you write a repeating decimal, as we were doing on a previous page, we use a bar over the top of the part that repeats. It's called a repeating bar by some people, and some people just simply call it this, a repetend. Write that in your notes, a repetend. Repetend is simply the bar that is drawn above the repeating portion of the decimal. So 5.131313131313 could just be written as 5.13 with the repetend above the 13. 7.166666 forever can be written as 7.16 with the repetend only above the 6. Again, I say, don't get sloppy with this. If you put it above the 1 and the 6, then I'm going to think, and so is any other teacher that I know, that it's 7.1616161616. So it's very important. And here's one more example. Here's a repeating block of a 318. Again, you have to have it over all 3 of those numbers for it to represent this block of numbers. That's not too tough, is it? Okay, let's just look at a it looks really complicated decimal, and obviously it has some sort of pattern if you kind of look at it. It's got 5.142857285728. Oh, I think we see the pattern here. So we're going to write it as a repeating decimal with a repetend. I'm going to write it with a repeating bar, and we have to look to see what's repeating. Well, I think we can see it's this 2857 right here, right? So here's what we write. 5.14, and then we put the repetend only over the 2857. And if we were to operate on that and repeat like it's showing we should, we would get this up here. Okay, we would get this pattern. Okay, again, I stress, don't put the repetend over anything that's not repeating. If you do, you're going to end up with the wrong decimal number. Okay. We're going to do just a little bit of rounding with repeating decimals. It's not all that difficult. Let's round this particular repeating decimal. We have 5.316. Now it looks like the 6 is the only number that's repeating. Now first, of course, we have to know what we're rounding to. So if we're going to round to 3 decimal places, so that's tens, hundreds, thousands, okay? So 1, 2, 3. That means that this is the one that could be changed, and this is the one that we're going to look at. Now typically when you need to round repeating decimals, the first thing you're going to do is write it out with repeating numbers as far as you need to, so that it's out far enough that you can see how to round it. So in this case we have 5.31. The 6 should turn into a 7 because this over here is 5 or more. The next one, we want to go to 5 decimal places. Okay, so I write it with the repeating number 1, 2, 3, 4, 5, 6 places out. Even though we're only rounding to 5, you have to write to 6 so you see what that 6th decimal place is. And in this case, again, we have this 6 here, which is 5 or more, so that means that this 6, which is the 5th decimal place, is going to round up to a 7. Okay, here's one more to look at. I think we'll round to the 5th decimal place on this one as well. And this one has a whole block of repeating numbers. So 25.405, 405, 405, 405 forever. 1, 2, 3, 4, 5, 6 because we were rounding to the 5th decimal place. I wrote out 6 places. We look. This is the number we're looking to maybe change or not. We look over here and this number happens to be a 5, which qualifies for 5 or more. Therefore the 0 rounds up to a 1, and therefore we've rounded it. Not too bad. It's really not too bad. Lastly, the last thing I want to do today is I want to compare decimals that include repeating decimals, just so we can kind of take a look at that. First of all, compare usually means less or greater than type stuff or equal to. So we're going to compare 0.3 to 0.3 with a repetend. Now we're going to have to use some annexing zeros to be able to do this. So here we go. 0.3 I'm going to write first. Notice that I put in some annexing zeros so that I could take it out a little ways so I could actually see what it looked like to be able to do a good comparison. And then I put in 3, 3, 3, 3. I went out at least 4 decimal places. So if we look at this, we're going to look to see which one is smaller and which one is larger. And we're comparing 0.3 to 0.3 repeating. These two are the same. Okay? Then we get to this one. Uh-oh, this is 0 and this is 3, which means this one is larger and this one is smaller. So if we were to put it, write it down like we typically do comparisons, we would say that 0.3 is less than 0.3 repeating. Okay, one more. Only this time we're going to range. We're going to range them from least to greatest. And you always have to pay attention to that. I've seen people miss questions like this, but they don't, because they don't pay attention and they put them greatest to least. Pay attention. Look to see what it is they want. So this is 0.6 repeating, this is 0.6, this is 0.65. Again, we're going to use some annexing zeros. Alright, so we're going to write it out using annexing zeros, which I have done. Okay, so now I have 0, 0, 0. That's nothing there. I've got 6, 6, 6, 6, 6, and of course that goes on forever and ever. I've got 0.6 with 3 annexing zeros, and I have 0.65 with just 2 annexing zeros. I generally go out at least 4 decimal places just to make a good comparison. Okay, here we go. We have 0, 0, 0, 0. So that was all the same. We have 6, 6, 6, 6, 6, 6. That's all the same. And then we get to this one. And we have 6, and then we have 0, and then we have 5. Well, I would say right here, since there's a 0, that makes it the smallest. So we're going to list it 0.6. That's the first one because it is the smallest. Get rid of this one. Okay, now we're just comparing the top one and the bottom one. So we still have 6 and 6, and then we have 6 and, oh golly, we've got a 5 there. So then this one would be the next one. It is the next largest. It is not as big as this one. So we'd write 0.65, comma. and we'd cross out this one. Well, all that's left is, 0.6 repeating. Now, ladies and gentlemen, we have written this in increasing order, with this being the smallest and this being the largest. Again, I say be sure that you pay attention to how you want them written, so that you don't lose points because you wrote them the opposite way. Hope you enjoy this. Have an awesome day, and we'll talk to you later.